All right, so we should now be recording. All right, so I'm going to kick things off here with some presentation slides before I jump into a little demo of the functionality I'll be discussing in QGIS, which I think will tie in nicely to our discussion from yesterday regarding creation of custom interactive maps. So I do want to just quickly show how we can do that outside of the ArcGIS environment using free and open source software like QGIS. And also how we can take advantage of other functionality within QGIS to pull in free web services, map services specifically, that are made available by OpenStreetMap, Google, and other providers, which can be really useful for a variety of different GIS tasks. So I'm going to go ahead and share my screen and pull up slides for content this morning. All right, can everybody see? Great. All right, so today we're really going to be focused on functionality within QGIS that is specifically provided through web plugins. And the great thing about QGIS is that it is really extensible. It's a free and open source application that is cross-platform. It will run on a Mac, on a PC, on a Linux computer. So I'm hoping everybody today, regardless of your situation at your institution, whether you have access to certain proprietary software, proprietary databases or not, this is something we should all be able to do. Well, I guess assuming that you had a chance to install it, or you have the privileges to install software if you don't already have it on your machine. But hopefully this is something we can all have a chance to practice during the activity today. So I want to give a quick overview of how plugins work in the QGIS environment. If you've ever installed a browser plugin in Chrome or Firefox, it's kind of a similar setup where QGIS itself is free and open source, which means it is extensible. So, technically, if you were using QGIS pretty frequently and you figured out there was something that you really wish it could do, but it doesn't do by default, technically you could use Python to write an extension for the QGIS application, and you could even package that up and share it with the community if you thought it would be generally useful to a wider audience. It's not just something that would be something specifically only you would be interested in. And so there's millions of QGIS users all over the world, and as a result, many different plugins have been developed. And so there's a lot of great functionality that you can add to the base functionality of QGIS by installing plugins. In keeping with kind of the tenets of the QGIS community, all the plugins are free and open source, just like QGIS itself. So you don't have to pay for any of these. And they're really, really simple to add to your QGIS application. It only takes a minute or so to add a new plugin. I will mention that some plugins are widely used and tested. So some of these plugins provide functionality that is like, kind of integral to getting certain important tasks done. It's maybe been downloaded hundreds of thousands of times. Lots of people are using it. Lots of people are contributing to its development, and others are very experimental. So maybe somebody designed a plugin that was really specific to their use case, and they thought, well, they'll just go ahead and share it with others, and it only has a couple hundred downloads. Not that many people have tried it out or tested it, and it might be pretty buggy. So something to keep in mind, that you might see a plugin that seems really cool the way it's described, and then you install it and it doesn't seem to work, or it has a lot of issues. That can happen. I've run into that myself. But the plugins we'll be talking about today are very widely utilized, and they tend to work really well. Plugins can be installed using the plugins window in QGIS, which is shown below here. And once they're installed, they can appear in several different places in the QGIS interface. So for me, it's always a bit of a challenge. After you install a plugin, where did it go within the QGIS application? Which menu do you click on to access it? Sometimes a button will show up in a toolbar, sometimes it will not. You have to go to a specific menu and go to the drop down to find it. So that's, I'd say, probably the most frustrating aspect of using plugins in QGIS, is you don't always know where it's going to go. Fortunately, all of the plugins we'll be discussing today are all found in the same place. They'll be located under the web drop down menu in QGIS. So we'll be talking about three plugins specifically: Quick Map Services, which makes it really easy to pull in like a Google base map or an OpenStreetMap base map. And this can be really useful when you're working on a project where you want to maybe create a new data set, you want to digitize new features. Using these base maps for reference can make that possible when you otherwise don't have data for the area that you're working in. And one of the things to know about the Quick Map Services is we will be making an adjustment to its default configuration. So we see a screenshot here, this kind of middle screenshot that shows a button that says Get Contributed Pack. And that button is really important to really extend the functionality offered by Quick Map Services and increase the number of web map services that are available to you. So that's something that we'll be practicing. I'll show that in the demo in just a minute. And once you have installed those additional services, you'll see here in that far right screenshot, there are a whole lot of different useful base maps basically that you can bring into your QGIS application. So it can be really helpful. Another one that we'll be talking about today that will also be part of our activity is called QGIS to Web. Basically, what this does is it generates all of the code required for an interactive web map. So it's going to create HTML files, CSS files, JavaScript files, and it's going to save those to your computer. So this is not something where it automatically is going to push things to the cloud because there is no built-in cloud solution for QGIS like there is for the ArcGIS environment, where you have ArcGIS Pro as the desktop application, which is roughly equivalent to QGIS. There is no ArcGIS Online that is free and open source, which makes sense because it's when you're talking about things that are free and open source, there's no company behind it to provide resources that cost money, like server space and all of that. So with QGIS to Web, it gives you a lot of control over how your map is developed. It gives you complete control to then go in and further customize things by editing code yourself if you wanted to do that. The biggest challenge here is that where do you put those files once you generate them? You would need server space to make them publicly accessible, and controlling access to anything you put on a server is difficult if you don't have a platform built around your map like you have with ArcGIS Online, where you can create groups and share with specific people and all of that. So that's the thing to consider here when you're actually working with a custom map like you would create with the QGIS to Web application. But the process for creating these web maps is really, really simple. We'll walk through it in just a few minutes here after we finish our last couple slides. Yeah, so I won't go and spend too much time on this, since we'll see all of this in the demo. And this is what the plugin looks like when you're using it. And then the last one we'll talk about today is very similar to QGIS to Web. It's really built around a lot of the same code, but the difference here is that it allows for 3D visualization. So I think everyone will be kind of impressed here by just how easy it is to create a interactive 3D map using QGIS in like 2 minutes using this plugin. It's pretty cool to see it work. It's something you would think would be really complicated, but this plugin makes it pretty easy. And so, like I said, very, very similar to QGIS to Web. If you're already used to using QGIS to Web, which we'll build some familiarity with that, using QGIS to 3GIS is kind of just a logical next step if you have 3D data. You just have to configure the settings so that it can read your 3D data correctly, and that's about it in terms of extra work required compared to creating a 2D map. And same thing, it will save all of the code required for the interactive map in a folder on your computer, and then it's up to you to make that available to others by putting it on a server somewhere if you wanted to share it. And this is what that plugin looks like, and we can see this 3D model of a part of Texas here. And are there any questions so far after this overview? All right, let's get into the fun part and do a little demo. I'm going to open QGIS. And does everybody have QGIS already installed on their system?
Michael, I don't. And I see that you have 3.14. And so when I was looking at the options, the page that I brought up for download is version 3.20 or 3.16. Now, I didn't know which one you would advise.
Either one should be totally fine for what we're doing today. I would go ahead and install 3.2 if you don't already have QGIS on your system. All of the 3 I mean, really anything past like 3.6 is going to be pretty stable and all very similar. There's not a ton of major updates happening between these point releases. As long as you don't have like QGIS2 on your machine, that is pretty out of date at this point. But anything, I'd say QGIS 3.6 or above is going to function in almost exactly the same way that you will see my QGIS 3.14 functioning today during the demo.
Thank you.
All right, so we're in QGIS right now. And we are going to first install or take a look at how you would go through the process of installing these plugins. So I already have them on my machine, but if I wanted to install them or even verify that they're installed, in case some of you have perhaps installed these in QGIS before, you would look at the top menu bar up here, which is going to be pretty important for us because, again, this is how we're going to find those plugins as well once we have them installed. We're going to click on the plugins button up here. We're going to click Manage and Install Plugins. It'll take a second to check which ones we have installed, and then it's going to pop up the Plugins Manager window. And you will see that there are, I don't even know, I haven't counted, but I bet there's well over 100 plugins in here. And they do all kinds of different things. Some are specialized for very particular purposes, like if you're doing flood analysis, there's probably plugins for that. If you're doing 3D analysis or creating things for the web, like we'll be focusing on today. If you want to, what are some of the other ones? There's metadata plugins in here. Those ones that I've experimented with haven't worked all that well. It's really something to explore if you're ever interested. There's some really cool niche ones in here. And you can tell which ones you have installed because they'll have a check mark next to them. So you can see most of these I do not. And I wouldn't recommending plugins that you don't think are going to be useful to you. Really, just focus on the ones that you think would be helpful, because the more you install, the slower your QGIS application will be to start up when you initially open it. So we're going to keep scrolling until we get to the Qs down here. And we see I do already have these installed because we see the check mark. So there's Qgis23js and there's Qgis to web. So you can also uninstall a plugin at any time, so don't worry about permanently committing to this. So what I'll do is actually uninstall Qgis23js so we can go through the process again of reinstalling it. You'll see it has over 500,000 downloads, indicating it is pretty popular. That's going to be one of the higher download totals you'll probably see for a plugin. So now let's pretend, I had never had it installed before. I would scroll down, see, oh, I don't see a check mark next to it. I'm going to click on Qgis23js and I'm going to click Install Plugin. And usually it'll take maybe 30 seconds to a minute. It's typically pretty quick. You can also see how these plugins are rated. So you can see that not only is it widely downloaded, it's also very highly rated, which is a good sign. If we look at Qgis to web, we'll see also very highly rated and has even more downloads, almost 750,000. And go ahead and upgrade that since it looks like there's a new version available. So you can also upgrade plugins that won't happen automatically. So that's a good thing to check periodically as well. Usually, that will help make the plugins a little more stable or maybe add additional functionality that's been contributed by members of the community. So now we're installing Qgis23js, we're upgrading Qgis to web, and then there's that one additional plugin that we'll install here in a second, or at least make sure it's installed, and that's Quick Map Services. So we'll scroll down a little bit further. We can see I already have it installed. New version available. I'll also upgrade this one. We can see that it has over 2 million downloads. So this one is extremely popular, again, very highly rated. So these are all good ones to have on your computer. You just never know if you're using QGIS pretty regularly when these might come in handy. All right, so all of those have installed successfully. And you'll see up here, I get a warning. This has nothing to do with the plugins that we are working with. This is about a different plugin, but if you install a lot of those experimental ones, you might get these errors more frequently, just saying that there's something wrong with them when you boot up QGIS. All right, so once we have those plugins installed, I mentioned it can sometimes be a challenge to figure out where they ended up in your QGIS system. So in this case, there are actually buttons that will appear in your toolbar. And if you're not used to the icons here, you might not realize it initially. But there is the QGIS23js that you can access through this button. This button will create your web map using QGIS to web. But usually the easiest way to find these is under the web menu, since that's where they all live, all three of them. So after you verify that they're all installed or have installed them, then you would go up here to web and you'd be able to access them. So the first one we're going to use is Quick Map Services. And yours might look different than mine if you have just installed it for the first time. And that's because I've already modified some of the default settings. So I'll show you how we go about the process of adding some additional web map services, and so that yours will look like mine in the interface. And so what we'll do is, after we hover over Quick Map Services, we'll go down to almost the bottom of this context menu and we'll select Settings. And there's one important setting that we want to modify for this plugin. And that is going to require us to go to the More Services tab. And we're going to want to click Get Contributed Pack. So this is going to add some services that are proprietary but freely shared, basically. And once you've done that, then you should see your Quick Map Services plugin function in the same way that mine does. So let's start off with kind of one of the stalwarts here, which is Google Map Services, right? These are ones that we probably widely utilize on a fairly regular basis. And I'm going to click Google Road, and just that quickly, our Google base map, right, that we're all pretty used to, has loaded here. And we can zoom in and we can see that performance usually is pretty good, with these services coming from Google. And so now what I could do, and I would say the thing that these are probably most useful for is, of course, if you have data like, yesterday, right, we were looking at institutions of higher education in the United States. You wanted to bring that data into QGIS and you didn't have a good base map. And so you just see these points floating in space. Well, using this plugin, now we have a base map and we can start to see, oh, UT Austin is located right here, and Southwestern University is located up here in Georgetown. And we now have spatial context for these points. They're not just floating over a white background. So it's really useful for just those kind of quick previews, or if you wanted to, create a print map and have a nice standard background that everybody's used to, like Google Maps. It can also be useful, and we'll turn on some other services here really quickly. I know we're short on time, but if we turn on the satellite view, and this is something that I allude to in our activity. So I'll just zoom in on UT Austin pretty quickly here. So here's our campus. So if we wanted to create a new data set, let's say, we're working or helping students with a project on campus, and they're trying to map the trees, right? They're going to do a study of the trees on campus. What we could do is actually use this Google base map and then create a new point data set, and we'll call it trees. And I'll save it to the desktop.
Michael, what did you click for the new shapefile layer?
It's this little button up here. It probably will be in approximately the same location for you. It should appear by default, but it's this little kind of squiggly line feature with the vertices visible. So if you click on that, you'll see a drop down, and then you would collect a new shapefile. So here, just really quickly, I'm going to say I want to create a new point shapefile, and we'll create one attribute field, and we'll call it species. I'll add that to the species list. Also, quick demo of how you would do something like this in QGIS in case you haven't done it before. But QGIS is pretty easy to get started with, and really good for these things. Just as capable as ArcGIS software would be. And then I'm going to start editing that shapefile, and I'm going to click the create points tool right here, and I can start mapping the trees. And I can say this is a live oak. And there we go. And so now I can just keep going along here, and I could say this is a cypress tree, or whatever it happens to be. And so just like that, we can start to create new features based on what we see in these services that we're bringing in. And that's really powerful. Otherwise, if we didn't have access to this, it would be much more difficult. We'd have to go and get imagery for these areas and download those files and do all of that. So that is how we would use the quick map services. And I'll mention a few of the other ones that are really nice. The Stamen base maps are pretty well designed. And you can look through different ones that they'll have fairly similar road-based maps, but the colors might be a little different. So you can find one that maybe fits the aesthetic you're going for if you're producing a nice map. And then the OSM ones are also really nice. The standard open street map is a really good one to utilize as well, since that's also free and open source. Any questions about the Quick Map Services plugin? All right. So now that we have, well, actually, I can maybe.
Question for you, Michael, before you continue. I'm thinking, are there like tutorials, like basic, like intro to using quick web maps or something somewhere?
The quick maps, I did in the suggested resources for today put links to the documentation pages for all three of the plugins that we're covering. So you could refer to that. Okay. And that's probably the best place to read specifically about the plugins. And in terms of QGIS documentation, there's all kinds of documentation on the qgis.org website, like detailed guides for how to get started with QGIS if you haven't used it before, that will like walk you through the major functions of QGIS. And there's then the general reference guide that explains every single thing that basically QGIS can do. So yeah, there's just a ton of nice documentation for QGIS.
Okay. Well. Thank you.
So actually what I'm going to do, just for the sake of time, instead of downloading another data set to bring in here, it might just be faster if I add another few trees, and we can create a web map to distribute this information. So let's say, I started mapping all the trees on campus, and we have maybe another live oak over here, and I'm pretty happy with the map I've produced, and I want to save this. And so I'm going to save my edits to this tree layer. And I'm just really quickly going to change the symbology so that we see different colors for the different trees that I've mapped. And we'll go to categorized, and we'll categorize them based on species, classify, and okay. So now the different species that I've mapped, and these are made up, I don't really know what trees are there, but we see them represented with different colors. And I'm feeling pretty happy about this, and I want to share this with somebody else, and I want to customize it, right? I really want this nice custom web app, and I want to do everything using free and open source methods. I want to try and avoid ArcGIS Online for whatever reason. I could go to web up here, go to QGIS to web, and say I want to create a web map. And down here, these three radio buttons allow you to select which JavaScript API you're going to use to basically facilitate the creation of the code required to make these viewable in a browser. So when you open a browser and you go to the New York Times website, or you go to your library's website, or whatever website you're visiting, those web pages are composed of HTML, which defines the content of the page, CSS, which defines the styling of the page, and JavaScript, which defines the interactivity of the page, and how the page will change based on things you're doing with your cursor, or based on like time sliders where things will swap in and out. That's usually done with JavaScript. And so we have those three major scripting languages that we need, or markup languages, in order to produce a page. This plugin is going to generate all of that for us, and it's going to use a JavaScript API to facilitate the creation of JavaScript files that allow us to do things like pan the map or zoom in and zoom out. So all of those functions that control that behavior are basically defined in these different libraries, and they're defined slightly differently in each one. You won't probably notice much of a difference by switching between these three, but if you notice that there seems to be an issue in the preview that you're given here, try changing which one of these APIs you're using. And I usually prefer Leaflet. It's one of the strongest ones, I feel like, in terms of reliability. This is really important. We can adjust all kinds of things here under appearance. So I can change which attributes appear. I can change the background color, whether certain tools like a measurement tool show up here or not. I can update the preview if I make changes to see how that will affect the map. And now we see a measurement tool appears. And so all of this just requires clicking some buttons, and it actually changes the underlying code that will be produced. Now I'm also going to go over to the export tab, and I'm going to select which folder I want these files to be saved into. So this is really important to make sure that we know where these are in case we ever want to upload them to a server, or if we want to go in and customize these files that it's generating for us. And I'm going to call it example web map. So this will be the folder that goes into. Like that, okay. And then I'm going to just go ahead and hit export. And we'll notice it's automatically going to open my browser. So here I am in Firefox, which is my default. And now I can click on these points and see my color-coded trees. And we have pop-ups already enabled. I can click on them and see the information. We can see the measurement tool that I decided to turn on. I could republish this and decide to turn that off. I can turn other tools on. And we're seeing that Google base map as well. So I can add multiple data layers here if I wanted to. We can publish just the trees with no base map. We can add an additional data set showing light poles or drinking fountains or building outlines or anything else. And I will say that the main limitation of using this plugin, besides having to figure out web hosting and all of that, if you're interested in sharing it, is that it has a tougher time than ArcGIS Online would if you had thousands of features, or if you had really complex polygon features with thousands and thousands of vertices. Then it would start to bog down the performance a little bit. Are there any questions about the QGIS to web plugin? All right, so I'm going to do one last demo here, and I know we're short on time, Josh. I'm keeping an eye on the clock. I'm trying to give you as much as possible, but I do want to fit this one last thing in very quickly. I'm loading in a digital elevation model that I already had on my system. And we're not going to cover QGIS23js in the activity today just due to time constraints, since it's a little more complex. But what you could do is download any digital elevation model you find online, and there are all kinds of them that are available through the USGS and other similar agencies, in different countries across the world. And we're going to use the QGIS23js exporter here. So you basically need at least one 3D layer to make full use of this. And under DEM, I'm going to turn on that new digital elevation model layer that I've added. You can see it's trying to prepare a preview of that for me. So this is a pretty big file, and usually DEMs are pretty large. And we'll notice that by default, it's flat. So here's the little preview. It's already interactive, but I'm not seeing any elevation. Nothing's popping up. And so what we need to do is customize the scene settings. And I'm going to make the elevation here pretty exaggerated. So I want to see 24 times exaggeration. And now we see those elevation differences really popping out. So if I was going to go for a hike in this area of Texas, and I wanted to get a better idea of the route I was going to take, and you can add multiple layers here as well. So I could have the trails. So yesterday when we were doing Sylvia's exercise or following along with the demonstration, we saw that there was the that trails layer that was available through ArcGIS Online. And if I were to add that Texas State Park trails layer and then bring in this digital elevation model, I could actually see what it would be like to go up that trail and see, oh, you know, it's pretty flat. And then all of a sudden you have to go up this pretty steep slope, you know, a couple miles into the hike. And you could create an interactive 3D map of that. So this is just the preview that I'm looking at. And so let's say I'm pretty happy with how this model looks currently. I can go to File and Export to Web. And same thing, I'm going to need to browse to the location where I want to save this. So I'll call it example 3D map. I'll export. And like I mentioned, you know, this plugin functions in much the same way as QGIS to web. It'll take a second to process. It's generating the HTML, the JavaScript, and the CSS files. And as soon as it finishes, it should have opened that automatically. Let's see if it's just taking a second here. Oh no, looks like we have an error message. Let's see if this will work in Chrome. So it should look exactly like the preview that we just saw within QGIS. Maybe I shouldn't have updated that plugin before doing this demo. Thought, oh, it's only going to get better. That's not good. You need a modern web browser. Well, we definitely have that with Chrome and Firefox.
If you were to put those files on a server, it would work beautifully.
Yeah.
I think it's a pretty big vulnerability risk to run Ajax locally like that. Yeah,
I think that's exactly what it is. And so I haven't seen this error before. I bet this is due to upgrading just right now. So unfortunately, it looks like we're not going to be able to see that. But I mean, basically, it should look just like the preview. And Josh, I think you're spot on there that if we were to copy this over to a server and then you were to request it from that server, should work beautifully. There are ways I'll mention where you can simulate that on your computer, have like a server, you know, like a testing server application running that allows you to access it on your own machine and it will think it's going through a server. Yeah, much too complicated to get into for a demo today. But if you were actually looking to generate an interactive 3D web map to share with others, basically, if you have that server space, you should see this once you put it up there and you go to that URL. So some pretty cool free and open source tools that, again, make use of WebGIS functionality, either for creating interactive maps or for consuming web map services that have been produced by other organizations or companies. All right, are there any questions?
Cool.
All right, sorry, Josh, went a little bit over there.
No problem.
But I'll go ahead
Now's
and turn it over to
probably
you.
a good time for a break, but before we do break, if you, just so we can be ready when we come back, I just put the direct link to the guide that we're going to be using, resources, links, instructions, all of that. So if we just have that up, we won't need any software. So just the web, and we'll be set for today. What kind of break have you been doing, Jennifer? About 5 minutes? Let's do that.
All right, sounds good.
I had to go to the bathroom. That also, that also is why I was pushing for a quick meeting, a quick break. Much better.
Tell us more about what happened. Was there a spill or chemicals or something? I just caught the tail end of that.
Yeah, it's some kind of chemical spill nearby. So it's, yeah, fun stuff.
Are they asking you to shelter in place? Like don't be outside?
Technically, we are just barely outside the shelter in place zone, and we're also just outside the evacuation zone. So, yeah.
Well,
I don't know.
we'll be thinking of you today for sure.
Well, thank you. Yeah, the helicopters are circling. It's kind of, it's a little distracting. But I think it's okay. I mean, this kind of thing happens more often than not. I mean, there's no telling what kind of chemicals we're exposed to on a daily basis. I'd rather not know.
I totally agree with that. Josh, I'm excited about today's lesson. I used Google Collab just a little bit, and I'm hoping this will really pump me up.
We're gonna bump it up. But I tell you, Michael, I've used QGIS a bit, especially when I was at the University of Houston. A number of departments, including political science, even though they've got the full ArcGIS license, the chair of the department mandated that open source was always to be used as a preference over commercial software. And they had such it permeated from all the faculty through the students. They wanted nothing to do with Esri. It was all QGIS, but I've never seen this. That was very cool, using those plugins.
I did an intro once, but I've never actually used it in a boot camp. But beyond that, I never used it. So I'm willing to go out and try it and see how it works.
Yeah, I mean, I'll say that, you know, I use both all the time, ArcGIS Pro and QGIS. I definitely default to QGIS. It's my preferred application just because it's free and open source, and you have that flexibility. And, you know, anybody else anywhere in the world can replicate what you're doing because they'll have access to it, which is nice.
Yeah.
If I can get someone from IT to allow me privileges to install it, I will have access to it.
So you just go out on the web and click and find QGIS to install, or you have to go to GitHub to install it?
Oh no, QGIS is really, really easy. You know, whether you're using a Mac or PC or whatever type of computer you're using, you just go to qgis.org and then click download. Or thank you, Jennifer. That's the full download.
Okay, yeah. Maybe I should have done it during the break.
Oh, hopefully Jennifer and I can give you. Oh, it looks like Alex made me host, so I can go ahead and give you screen sharing, Josh.
What version did you say was best to download? Is it 3.2? Oh,
yeah, I would just go ahead and download the latest version.
okay.
Yeah, if you don't already have it installed.
All right. We ready to go? All right, so I'm pretty excited here today because we get to delve into Python and Google Colab. If you've never programmed before, Python is super easy to learn. I'm just a librarian, nothing fancy, no computer science background, no IT background, just a librarian, originally in GovDocs, and now largely due to how easy Python is to learn and use. I work primarily with data. Now, even as easy as Python is to learn, the learning curve is a bit more than we have time for this morning. In our approximately 45 minutes, we are going to build a web application that will allow other users and researchers to upload an Excel file and generate an interactive map. So what software will we need to download to create this web application? None, nil, zilch, nothing. What software will researchers need to use our web application that we create? The same, nothing. Now, if you're pointing and waving your fingers at me and exclaiming, well, how can we do this with no software? I will tell you the freely available and public Google Colab platform. Do we want to see what Collab looks like? All we have to do is just search for Collab in your web browser, and it will be the first hit that comes up. The URL is research.google. Actually, I think it changes. collab.research.google.com. And I use Collab on a daily basis. So I've got tons of projects in that load up here. I'm just going to hit cancel, and then it takes you to the default Collab environment. Google Collab is an online platform, entirely online, that allows anyone with a Google account to write and execute Python code directly in your browser. Even better, Collab stands for collaboratory, meaning it is designed to allow you to collaborate with others on writing Python, and you can share scripts that you have written with specific people or researchers, and the ability to make a script available to the public so anyone can use the tool or script that you create. This combination of online Python coding with the ability to share with individual researchers or publicly makes the Collab environment an amazing tool for library research support. I have some examples in this guide here. Some recent examples of how we are using Collab at Baylor University libraries. Now, I will admit to you that text data mining and data visualization is much more of my day-to-day activities, what I do here, than GIS and mapping. So I apologize that these examples are not map-based, but these are tools that we've created either for colleagues like the first one, or the last two for specific researchers or groups of researchers. The first one that I want us to walk through so that we can get a feel for how, to the end user, to a researcher, how a researcher can engage with a Collab script that we create for them. And then we're going to go ahead and build our own mapping application from scratch. So the first thing that we want to do is so that we have some syllabi to play with, and we'll talk about what this tool will do, but we need some syllabi. You can have syllabi from your local computer, or I created this zip file that has 11 museum studies syllabi from Baylor. All we want to do is right click and copy that link URL. We need that copy. Then we can go ahead and launch the syllabi information literacy miner. Now, there are many different methods and formats to run Python code. Collab employs a format called a Jupyter notebook. This is the same format as the notebook Michael showed us yesterday through ArcGIS Online. Notebooks are made up of blocks of code and Markdown. Markdown is simply for displaying text, images, links, etc. This top block, if you were to single click this block and you see how this block has become activated, this is a Markdown block. It gives the purpose for this tool, an overview of the procedures. This one gives permissions, and I'm really happy that I am not the one listed to contact for information. This particular notebook has a single code block, which is down below. If we single click this code block, and we can see this is a code block because we have a run button. We're not going to run it quite yet, but we have a run button right here to the left of that particular block. Now, make sure you're logged into Google. You want to look at the top right corner, right where my mouse is hovering, where I have a J. I'm logged into a Google account using my Baylor login email. Doesn't have to be related to your institution at all. This is entirely free. If it has a sign in button, go ahead and log into any Google account. It can even be a YouTube account. Any of the family of Google products, you want to be logged into any Google account. When you launch a publicly shared Collab link, like we all just did, you are viewing a personal copy, your personal copy of the notebook that was created by someone else. Nothing you do will impact my copy or anyone else's copy, which is pretty freeing, meaning you can't mess anything up And if you do mess up, if you start tinkering with things, just click the original link and you will generate a brand new fresh copy from the master. Now, this particular notebook allows researchers to upload syllabi or provide a URL to zipped syllabi like we're going to do in order to mine potential information literacy concepts in a 3-tiered approach from the syllabi. As we are just trying to get an appreciation for Collab, we will make sure that the syllabi source down here into the code block, we want to make certain that this drop-down menu, we have 2 choices. You can either upload syllabi or enter a URL. We're going to go ahead, just for this quick example, we're going to enter that URL for the 11 museum studies syllabi. And we're going to leave the rest of the settings just as the default, because we're not really here for an IL instruction. We're here, we want to see what it potentially can look like, then we're going to get right back to mapping. So once we've made certain that it's enter URL to .zip archive, we click on the run button, and the output is always going to be beneath the code block. And so what it's doing right now is and we'll see how we're going to have to do something similar to this when we build our own from scratch. It's importing and installing any libraries that it needs. And what's taking this 30 to 45 seconds the first time you run the tool is there is a library called Textract, which is really, it's a large library when it installs, but it allows you to convert from any file format into nice, clean, pure text, which is great. So that's what one of the first things that it'll have to do. I'll go ahead and paste that URL right into where it says paste URL to zip file below and just hit enter. One of the first things that it's going to do, it's going to take the combination of, you can see there's 3 Word files and 8 PDFs, and it's converting them to text. And so in order to do that easily, we installed that Textract library at the beginning. So it is done. You will get a syllabi.xlsx file will automatically download. Like Michael uses, I'm in Firefox. If you're in a Chrome browser, you'll get that little pop-up in the bottom left. I'm just going to push this aside for now. We don't really need that for right now. And whenever you run code, it always takes you, like I put in bright red, you're at the bottom, right? So we have an outer window and a scroll bar and an inner one. We just want to make certain we get up to the top. And so this particular Jupyter notebook took those 11 syllabi, it analyzed them for information literacy concepts. In this 3-tiered approach, it found that the majority of the IL concepts that it identified were in this research in the disciplines tier. It gives us some visualizations. It shows us for each of the syllabi which tier it had at least one information literacy concept that it mined. And this is the granular information. This is a data frame, and we're going to learn about data frames. This is a data frame that is giving you every single specific context of information literacy concept that it found in the syllabi. And if you were to open the Excel file, it's this in the Excel file. And we're using this here at Baylor to be able to load massive amounts of syllabi, not just 11 museum studies, so that our liaison librarians can identify new courses that are not currently receiving a library instruction and identifying gaps and new opportunities. So I'm going to just hit cancel here. This is not the focus. Information literacy is not the focus of what we're doing here today. So I'm just going to go ahead and hit this X to close that tab.
Is it like curriculum mapping kind of thing you just did, something like that?
Yeah, what it does is there's a part 2 to that we don't share publicly. But what we have what that does is that identifies potential information literacy or potential library instruction opportunities. Then we have a Power BI, the same software that we use to run the GIS survey dashboard. We have an internal only Power BI dashboard that connects to an Excel file that notebook outputs, and it connects to our Spring Share instruction database. And it will specify within, you have a slider within the last 12 months or 24 months. We want to identify those particular courses that the Jupyter Notebook found potential instruction opportunities that we have not done instruction for in the last 12 months, 24 months. And then it just gives you a list of those courses, and it's just additional resources for our liaison librarians to contact those instructors and try and increase the amount of instruction that they do. So that's what that one does. That's Syllabi Information Literacy Minor. We're not going to run any of the others, but I just want to pull up. These are two that I'm actively right now working on. We have a researcher who is trying to use in vivo to analyze in the transcripts of interviews. The format of their interviews, it's messy. It's got times, it's just a mess. And manually cleaning that up was really getting to be a pain. So I created this specifically for that researcher and any others who may want it. They just have to click 1, 2, 3, and it spits out beautifully clean files. And this last one, I'm also currently working on. This is for researchers who are looking to using this Recogito to manually code content, specify this is a place, this is a person, and be able to take what they've manually coded and then train a machine learning model to identify those same things in other content. So this is a notebook that will help them go from Recogito, I don't know how to pronounce it, Recogito to a format where a natural language processing library, Spacey, can learn what they did and then apply it to other text. So those are some ways, and we can close those. Those are some ways that, and hopefully your imagination is really exploding for how you can, or working with others, like many of these projects, I'm collaborating with other librarians, how we can create custom tools, send it to the researcher, or if it's sensitive, we can send it only to one particular. The ones I shared are entirely public, and they can just run that tool. So that's what we're going to do here today. We are gonna, so I'm looking at this here, and let me make this bigger. We are going to build a web application entirely from scratch that will allow a user to upload an Excel file of addresses, and it's going to generate an interactive map that, similar to what Michael was showing from QGIS, it's going to create an HTML file, and all you need to do is download that HTML file and you've got it. And you can just put it anywhere you want or run it locally, and it'll just work great. So that's the example we're going to build here today. So here's that workflow, right? As we're designing our from scratch Google Colab notebook, we need to think through, right? Step one, they need to upload an Excel file. The next thing it has to do is we need to read that Excel file into a data frame. And a data frame is simply a way that Python can read and analyze tables of data like an Excel file, X and Y, rows and columns of content. So we'd read the file into a data frame. The third step we needed to do is to then geocode those addresses. It will calculate the latitude and longitude. And the final step of what our notebook is going to do is to create that interactive map. All right. So you may have a Collab tab already open, but I provided the link right here, and it's just going to open a brand new Google Colab environment. What I want to do is click the new notebook. If you don't have this pop up, you can also go to File, New Notebook. Either way, and it is going to generate a brand new blank notebook for us. Your may default to title Untitled 01.ipynb. The file format for Jupyter Notebooks is ipynb for Iron Python Notebook, which is the predecessor to Jupyter Notebook. It still has the same extension. But what I'm going to do is let's rename this. We can delete the whole thing, even the extension. And let's just rename this to create web map, right? So that now is going to be the name of our notebook. And if I went to file and open notebook, it's now the most recent one. And that's how I can get back to it at another time. But I'm going to hit cancel here. All right. I see there is some. Oh, great. Okay. So definitely do not hesitate to just unmute yourself if anything is unclear, going too fast, or if your computer is not responding like mine. It shouldn't matter whether you're on a Mac or a PC, everything should work fantastic. Let's see here. I should have said earlier that I forgot that I'm logged in and I created that syllabi information literacy miner. If you tried to run that tool when I did, you should have received a pop-up alerting you that you have to trust, and it would say Joshua Bin at Baylor.edu in order to run the script. I hope you would trust me. Anyone you share a notebook with, it's going to give them the email and say, do you trust this email? So if you share it with anyone in an official capacity, it probably is a good idea to use or create a Google account with your official email. Now, these security concerns with sharing these notebooks do not affect your personal computer. There's absolutely no connection there. The security concerns affect what can be done with your Google Drive account. So you want to make certain if you're running someone else's code, you're either not you either trust the person completely, or that you are not logged into a Google account that has some sensitive information. So here we are here, and you can see that we are in our first code block in our notebook on Google Colab. And it's pretty obligatory. I think when you first start learning a programming language, you have to make it say hello world to the screen. So we're gonna do that. The command here is just print. So if you type print, what you're specifying is not printing to a printer with paper, it's going to print it to the screen. And I hit, oh, also I can make this much bigger. That'll work. I hit print and open parentheses, and it gave us the closed parentheses, which is great. Then quotes, I typically use single quotes, but you can use double quotes. It doesn't matter as long as you're consistent. And then we just type hello world. It's not going to do anything too fancy. What I'm expecting is just beneath this code block, when we click run, it should say hello world. And there we are. And you see it always will put directly below the code block. If we want, what I'm going to do is I'm going to put the cursor all the way to the left, and I'm going to create a new line above. And if we were to put something like my name equals, and we put our name. And so what that is doing is it's storing the word or string, but the word Josh into a variable called my name. Then what I can do is get rid of everything inside of the parentheses and just put my name. And you see it has a pretty nice autocomplete where you can use tabs and clicks to autocomplete your code, and then just run. And it goes ahead and it prints to the screen the variable my name. So this is how the Jupyter notebook environment works. It's going to look slightly different than if you were in the ArcGIS implementation of Jupyter Notebook, which is much more similar, looks like the standard out-of-the-box Jupyter Notebook application that you can indeed install on your computer, but the Collab environment customizes it just a little bit. Now, what we want to do is we want to be able to go back and forth.
I have a quick question.
Yeah.
I don't know if this is something to do with settings, but on mine, I don't have my lines of code are not numbered. So I just have my name and print.
What we want to do, and this is going to be saved to the settings of the login you're using, is to go to Tools and Settings. And there's a couple of settings that I always do. I might be, let me get my screen back to a regular size. I think it was too big. There we go. So in settings, you can adjust the theme if you want, a dark theme, but under editor, the first thing is you want to click the show line numbers so that you will get line numbers. And the indentation width and spaces, the last I looked was 2. And 2 spaces for indentations in Python. For me, I can't see the indentations as well, so I always bump that up to 4. Those are the 2 things that I always do. But you can look through here and look at some other features that are available. There is a Collab Pro that I've never experimented with. And if you look at, while we're here, if you look under miscellaneous, everything under miscellaneous is a joke. You can specify these different power levels, some power, many power. It's all jokes, and it'll put little flashes of stuff across your screen, or you can have a corgi or a kitty running across your screen. Everything under miscellaneous is just for jokes and giggles. Fun to play with though, but what you were asking is right there, show line numbers.
Yeah, perfect. Thank you.
Yep.
Oh, I love the corgi.
Yeah, it's fun. So I just bumped I'm back up to 100%, 170% browser size. So now I'm big again. We want to, the next step is to download this Excel file. What I did is just like we looked at on Monday, I went to reference solutions. I filtered for ice cream locations in the Waco metro area. So there'll be some outside of the city. But if you click this, it will download to your computer. I might open mine just so we can see what's inside. But the most important thing is that it's downloaded to a location on your computer that you can remember. Like I think the default should be in your download directory, because we'll need to upload it to the Google Colab environment. But I'm going to open mine first, just so we can see what's inside. It went to the wrong, here we go. All right, so it's very simple. It has the name, and you see we only have 22 ice cream places, but we have the name of the company. It gave us the executive first and last name. We have the address, and these are all verified locations, something that's built into Reference Solutions database. If you don't want only verified, meaning someone from Reference Solutions called the company and verified the information, you perhaps can get more records, but they'll be unverified. So that's what's in there, very simple file. And now I'm going to go ahead and download one. And it's going to put it right to my download directory. That's the default for me. Then what we're going to do is we're going to scroll down to where it shows code snippets. And for each step is going to be its own code block in our notebook environment. For the first step 1, it's just 3 lines. And I'll talk through what these lines are doing. What we want to do is select those 3 lines and copy them, or Control-C copy them. Go back to our create web map. And I'm going to just delete what's in that first code block and paste. So what this is doing is this is first importing from the Google Colab environment a files library that's going to allow us to upload files, download files very easily and efficiently. So the next line is going to take the files that were uploaded and pass it to a variable. For those of you familiar with Python, it's actually going to store this as a dictionary. And then just in case you upload multiple files, we're not developing this notebook to handle multiple files. This tells it to only take the first file that was uploaded and pass that into this Excel underscore file. So that Excel underscore file is going to have the name of the file that we upload. And if you upload multiples, it's only going to contain the first file. So let's see what this does. Let's click run. And look how easy that is, right? So nice. We hit browse. I'm going to go to my download folder. and the most recent. So I just have this sorted by date modified. So just 2 minutes ago, wacoicecream.xlsx, and click open. Boom, done. We have now uploaded that Excel file into the root directory of this application. If you want to know sort of where it's hiding out, you'll notice these vertical tabs here on the left. If you click the bottom one, which mouses over to files, that's where it saved it. If you need it, right? That's where it saved it, but we don't need that open, but that's where it went. So far, so good. Everyone was able to create that browse and upload. Next, I'm going to go back and 3 lines again. And what we're going to do is this is going to allow us to read the Excel file into the data frame. So we're going to create another code block. You'll notice if I put my mouse toward the bottom here, I have a code, and this would be if I want a text box. I want code. We want another code block. And paste. So what this is doing is this is importing pandas, which is an absolute must if you're working with data in Python. I'm going to go ahead because I've got the links here. You don't have to follow along. You can just watch on my screen. I'm going to go to the pandas website, and pandas is the default library that you will want to import so that you can read tables, work with tables, modify, relate tables, merge them, append them, run statistics and analysis on them. You want to use pandas. And pandas is the essential Python library, visualization, statistics, anytime you're working with a table of data. So you see that I put a hashtag or a pound sign at the beginning of this line with the URL. Anytime Python sees a hashtag or a pound sign, you'll see it turns it green in Collab. It knows to skip that. Pound signs are what we can use if we want to say this is a note to myself, right? This is where you could add notes for yourself or others so they can know what you were doing, but Python is not going to run that code. So the first line here is going to import pandas, and typically you would import pandas as PD, and it's going to read the Excel file. And you see the name is Excel file because that's what we called it here. And it's going to read the Excel file as a pandas data frame with the name DF for data frame. If we click run, there's no output, but what we don't want to see is an error message. If we want to see what the data frame looks like, we can go ahead and create a new code block beneath and just type DF. And it's showing us what it's got, right? So it looks just like the Excel file. So you see just how easy it is to import pandas, pass an Excel file as a new data frame. I mean, it'll take some practice working with it until it becomes second nature to just start typing, but Python is really so intuitive and so easy. If we want this cell, we can click on, so I have the cursor selected in here. I can click on this trash can, we'll delete it. But if I click on the 3 dots for more cell actions, we can tell it to clear the output so that the table vanishes. Let's go back, right? So let's go to our very next snippet 3. And snippet 3 is going to geocode, it's going to install and register our geocoder. So let's start with the hashtag with the URL all the way down through this last hashtag and copy it. And let's put it, I'll create a brand new one and paste. So there's a couple of things happening here. First, we are using the Geocoder library. Unlike pandas, which remember we imported pandas, Google Colab has an enormous library of already pre-installed libraries and modules that you can just type import pandas as PD, Pandas is already installed in the Collab environment and you're ready to go. Similar to, of course, this is a Google Collab library. We imported files, but we didn't have to worry about installing that either. But this Geocoder library that we're going to use is not pre-installed by default in Collab. So you don't have to do this, but I want to show you what's going to happen. If I just make a new cell here and type import Geocoder and run, it is going to tell me there, it doesn't know what Geocoder is. It can't import it. So we would say, aha, I'm going to delete this. We'd say, aha, we need to install it. So what this is doing is this is a way using this try except that you can test to see if there'll be an error. And if there is going to be an error, then instead of it generating the error we saw, we tell it, if this crashes, don't give me an error message, do this instead. So this line is installing the Geocoder for us into our instance of the Collab environment. And then once it's installed, then it will go ahead and do what crashed here and import it. So let's run this and you'll see what's going to happen. Perfect. This line right here, if we were to put a hat, well, what this is doing right here, again, if you're familiar with Python, this is a Linux Unix command that tells the command to not write the output. So we didn't get all of the downloading, building wheel, installing, none of, all that was suppressed because of the ampersand greater than dev null. If this was not there, we would have seen. Now, the reason why we would do try and accept is because the next time it's just going to work instantly, right? Because we already installed it and we don't want to install it every single time. So the way that we would get around that is to try to import it. And if it works, great. If it crashes, it will go ahead and install it and then import it. So it's a really nice method using this try except. Now, did I miss out? Oh, I did miss. If you missed as well, like I did, there was one more line with the page break because we need to talk about the Bing key. In order to geocode using Bing maps, like we're going to use the Geocoder library, it needs, the Geocoder library just makes it really easy to geocode with Google Maps, Bing Maps, any of those online web mapping services, but we still need a key. Key is free, but we need a key in order to geocode based on their open API. If you go to that URL, let me do it from here. Now, I don't want us to take the time for everyone to register, but what you'd want to do is just sign in with any Microsoft account because Bing is a Microsoft mapping tool. It can be a Hotmail. It can be, if your work email has a Microsoft authentication, you can use your work email and you can very quickly generate an API key. Now, I made one this morning. And right after our session, I'm going to remove it. It's right here. So instead of us taking the 10 or so minutes for everyone to register for a key that you would at that URL, bingmapsportal.com, if you copy that key and put it right inside those quotes, just like when I put my name equals Josh inside of quotes, that is the Bing Maps key. And then we want to make certain we run this cell so that that line we just entered, it now has a variable called Bing key, and that is going to be the code. Now, what we're going to do before we finish here today is we're going to make sure that we create a text box so that an end user or a researcher can just go ahead and paste their own key in and not have to manually hard code it into the code like this. All right, so let's go back to the next step, which is step 4. And this is going to geocode the addresses. So starting with create empty lists and down to df confidence equals confidence, copy it and into a brand new code cell and paste it. You can see I added some comments here to help walk us through what's happening. One of the types of data constructs we can work with in Python is a simple list. A list is just a one-dimensional array. It's just a list of items. If we have a list of the numbers 1 through 5, it would be 1, 2, 3, 4, 5 would be a list of the numbers 1 through 5. Before we add things to the list with this dot append is how we add things to the list. We have to create the list. So we created 3 empty lists, one to hold all of our latitudes, one to hold our longitudes, and one to hold the confidence or the accuracy that Microsoft Bing has for generating the latitude and longitude. What it's then going to do, it's going to cycle through the data frame. Remember, the data frame was called DF. So it's going to cycle through the data frame every row. It's going to go row by row by row through the data frame that was the Excel file. And for the first row, it's going to take the content that's in the address column, and it's going to write that to a variable named content. Then it's going to use the Geocoder library that we imported earlier, use the Bing. It's going to pass the address. It's going to send them the key, and it's going to send back this G object that's going to have all of the geocoded information. We're going to add to the latitude list. We're going to append the latitude, the g.lat, to the longitude, the g.lng, and we're going to append the confidence, which is going to be high, medium, low. It's going to be the 3 categories of confidence. Then what it's going to do, the reason why we make those 3 lists, it's going to add those 3 lists as new columns to our data frame. Longitude and confidence is going to equal those lists that we had created. So let's give it a shot. Let's click run. And if there was an error with the Bing key code, you would see an error message. There's no output here, so no output, no error message is great. If we want to see the data frame now that we've added 3 new columns to it, just like before, add a new code block and type DF. How about that? Company, executive, executive address, record type, latitude, longitude, and the geocoding confidence.
I did get an error message on mine.
Oh no, what, do you want to share your screen, or do you want to describe what it says?
Yeah, it says there's an issue with line 11, indentation error. Unindent does not match any outer indentation level.
In Python, I don't know why the copy and paste may have worked different, but you see how we tell it that we want to iterate or cycle through all the rows? It knows to stop cycling when the indentation ends. So this indentation is not simply for style or readability. That indentation is required. You want to make sure that everything, right? So if I hit back and then tab, you want to make certain that everything is aligned perfectly. If you have one that has even one less space or one more space, get them to be aligned perfectly and then try it again.
Yeah, it had a space, but it's still, I ran it again. And it still gave me the same error message. Weird.
Michael, can you give, let me stop sharing. Can you give, is that Alexa?
Yeah.
Can you give Alexa permission to share her screen and we'll take a look?
Yeah, you can share now.
Okay.
Did it work for everyone else who's following along? Or if you're just watching, it's working for me.
Yeah,
Can I ask a quick question? Are you going to put that key code that you pasted into the instructions?
Well, I'm going to actually remove the key code after this exercise.
Okay.
And I think people would want to, because it'll just use, oh, I see the, how funny is that? All right, so let's take a look. And Michael, you can help me too. What's going on here? It looks like everything is lined up.
Yeah, so it shows this like extra spaces, I guess.
You know what? Let's try this. Select everything from line 8 through 13, and then hit Shift Tab, which will dedent, and then tab. Let's try that, and then click Run. It's hitting the geocoder. Ah, that was it. There was something weird in there
Okay.
with those tabs. So we got that fixed. Excellent.
All right, now I can stop sharing if I can. Where's my menu? Oh, it's on this screen. That's so weird. There we go.
Fantastic. Let me go back to portion of the screen. All right. So, and then if you were to create a new code block like I did and just type df, it's going to show us all of our geocoded points with the latitude, longitude, and the confidence. I'm going to go ahead again and use for this cell, I'm going to click the clear output just so we don't have all that to scroll past. So we're up to the last step, which is generating the interactive map with another library called Folium. So let's start with the # or hashtag in that URL and down to m.save index.html, which is where it's going to save our web page, and create a new code block and paste. So Folium is fantastic. Let me go and launch the website. Here we are. And what it does is it makes it super, super easy to generate an interactive website or web page with the leaflet.js, which is a very popular open source interactive mapping library. And you see just how easy it is. We need to import Folium, but we don't need to install it. So Folium comes pre-packaged with Google Collab. And what we do is we first are going to create this M object for our map. It's going to be a Folium map. And I'm telling it what the coordinates are for the initial start. I'm telling it what the zoom level should be, zoom level of 6. And for the base map, we're going to use the OpenStreetMap streets as our base map. All that can be adjusted. We're going to do that in a moment, but that's going to be the default here. Then again, we saw the same syntax. We're going to cycle through our data frame. And every time it goes row by row by row, it's going to add as a Folium marker the latitude and the longitude. We can enable pop-ups, we can enable tooltips, but not for right now. It's going to add all of those objects to the map, which is we defined here as a Folium map. It's going to display it for us right beneath, and then it's going to save it to index.html. So let's run it. How about that? Right, so of course, we can change colors and we can make each category or name because there's a lot of Dairy Queen in the area. But here's the Waco area. These are each of our points. It's using the OpenStreetMap in the background. And if we look in the files here, remember that's where the Excel file was. Now there's also an index.html. And that index.html, if I right click and download and just tell it to open in Firefox, right, we just get our map. Right, so it just works. And you can put that in, we use WordPress quite a bit here. So if you have WordPress at your site, you could request a WordPress account and embed this into a WordPress site, and you'd be set and ready to go. But just like Michael was talking about earlier with the QGIS, there's no web storage provided other than it's displaying it right here for us, right in line. So are there any questions so far?
Cool.
What we can do now is if we go to edit and clear all outputs, now we're back to our original, we see all of our code blocks. Now, if you remember when I was running through the examples, the syllabi information literacy minor, for example, we didn't see code, right? But we could. So if I went back to the syllabi information literacy minor, you don't have to, I just wanted to show you. All I have to do is double click on one of these code blocks and there's the code. It's all right there. but we have the ability to hide the code if what you're looking to do, and I can just double click here and it's hidden again. Maybe if you're writing this for someone who does program and you want them to be able to modify, cleaning this up, but sending them something like this can work. But if we want to hide it and give labels and make it a bit more usable as something the library can generate for researchers, what we do is put the cursor in the very top code block, the one where we imported google.colab and uploaded files. And you will see the 3 dots hovering on the right, and you want to add a form. We don't want to confuse this with Google Forms. This is Google Colab Forms, which allows us to create a form directly inside of the Collab environment. So you see what it did is it put $, ampersand, or @, and then title, and then default title text. Instead of default title text, let's specify upload Excel file. And then if you double click on the form here, how about that? And you just click run, and there it is. I hit cancel, so I get a crash. So I'm just going to use this and clear output. Right? Then we go to this one. Same thing. Add a form. And maybe we can call this read Excel file to data frame. There we go. Step 2. This isn't really a step, so I'll hit delete on this one. For this one here, what it's doing is it's importing the Bing, right? So I'm going to go in and tell it import Geocoder. For this one, this is going to geocode our addresses. I'm looking at the time. I want to make certain geocode addresses. I'm going to delete this DF. We just use that so we can print the DF and see it. And for this very last one, I'm going to add a form, and this is going to be create interactive map. All right, now it's nice and clean, right? There's a lot more we could do, but this is a really nice, clean web application that we can send to someone. We can also add, using those Google Forms, we can add a bit more information. Like, for example, let's say that we want to ask the user for the Bing Maps key instead of having it embedded in the code itself. Let's do that. So back to our web map. What we're going to do now in the import geocoder, if we double click, we'll be able to see the code again. If we want to remove the form entirely for now, we can hit the 3 dots and form and hide form. But I don't think we want to, but that's how we would. What we're going to do is we're going to comment out this line, or even better, delete this line entirely, right? So right now, there is no Bing _ key variable. So when we run this one, it's going to crash because we don't have the key defined here. What we're going to do though is, so I deleted that line. Then in this same code block, I'm going to hit the more cell actions and form, and I'm going to add a form field. We have a number of form fields. It can be a dropdown. It can be an input text box, a slider, markdown if we want to enter some text. We want an input box, and the variable name is going to be capital B for Bing _ capital K for key. Variables are case sensitive in Python, so we have to make certain it's capital B Bing _ capital K key and save. So in the form header here, it now is going to expect a string, which is text, and pass it to a variable named Bing key. Just double click on import geocoder. How about that? Now they would run upload Excel file, and maybe I'll just run through the process here. I'll browse, I'll pick the Waco ice cream. I'm going to read the Excel file into a data frame. We would probably put a message here saying specify Bing key and then click run, right? I don't remember what the key is. Do not have that memorized whatsoever. Where did I put it? Let's see, it is, there it is. So they would have to come with their own key, and you can provide links and information for where they're going to register. Then I run this one. Then I can geocode addresses. And once that's done, and you can always see on the bottom how long something took. So that took 4 seconds to geocode those 22 addresses and then to create the interactive map. Right, so those Google Colab form options are really fantastic. We're going to add one more form type. So if we go into the create interactive map and just double click, right now we have the zoom start to 6. If we put a £sign before it or just control// on that line, it will comment that line out for us. And I want to create a variable called zoom start. So I'm going to go to our form. I'm going to add a form field. This time I'm going to use a slider, zoom_start. Maybe min should be 1 and max will be 10, and it'll increment 1 with each. Now we've got a slider. And how do we want to do that? Let's see if that'll work. I didn't think that part through. We'll see if I can take zoom start and pass it to zoom start. We'll see how that works. So the larger the number here with this slider, the more zoomed in it will be. I'm going to go ahead and put 10 and click run. Oh yeah, that totally worked. So that worked well. I can do that. I was a little bit nervous whether I can or not. So that's everything I wanted to go through. Hopefully, again, not saying that you can now immediately start coding your own mapping applications in Collab, but I just wanted to show you it's really not that hard to learn to do. Python is such an approachable language to learn for a librarian just like me. And Google Colab makes it so easy and fast to run your own code and especially to share with others. We need to go through sharing. I'm going to click share on the top right here. And it's going to look just like the standard Google sharing options. I'm going to change this to anyone with the link and copy that link, right? So now I have that link copied. If I were to open, let's say, a private in Firefox anywhere, I can do Control-Shift-P. That's going to open a private browser so that I can test something without me being logged in. I'm going to paste that. And you see now I'm not logged in and it opened up beautifully. I made a mistake. I left my key in there. So I need to go back, take that out, and then I'm just hitting Control-S on my computer, which does work. And then I'm going to go ahead and try a new Control-Shift-P and paste. That's beautiful. We probably also wouldn't want to leave the default zoom start as 10, but that works well enough for now. So not that, of course, not that it's required by anybody, but I did develop an activity for the web mapping. Not do that. Let's do the 100% to fit. There we are. So here is, if you were not following along, here is the finished product. Right, so there's the URL. It should be in that Word document now. This is the activity mapping with Google. And what it wants you to do, if you want to give it a shot, is to add another form item to change what the base map is going to be. We are currently using the OpenStreetMap, but like those toner base maps that Michael was talking about in QGIS, these are additional options that you can use. So really what it would boil down to is going to the Create Interactive Map, Adding a new form field. I think a dropdown would work well. Give it a variable name, add all of the items here. You can keep on adding items. And once that is done, then where it says tiles equal OpenStreetMap, change that to whatever variable you declare in here, variable name. And that's it. And if you guys have any trouble or don't even do it at all, I'll go ahead and demonstrate that if we want this afternoon at 4 o'clock.
Yes.
All right.
Fantastic. Thank you.
Yes. Thank you. Let's see. Is the activity in the curriculum folder?
Yes.
Okay. Josh, you're muted.
In the day 3, you'll see the guide mapping with Google Colab and Python. That's what we use today. And the activity is, if you've got time. Yesterday, I had 0 time to work on the ArcGIS Online stuff. No one's going to hold it against you. I hope you wouldn't hold it against me. But if you did have the time and interest, the activity is what you can work on.
Oops.
Day 3 is the activities are linked in chat. All right, that was a lot, again, a lot.
Yes.
And so fun to watch now, maybe fun to try.
Right? Yeah.
All right, thank you, everyone. Great morning.
Thank you. Thank you, Michael and Josh.
See you guys at 4.
Thanks, everyone. See you soon.
Right. Bye.
Bye-bye.